Hello everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 2, Lesson 11, Fraction Multiplication and Products of Decimals. Now, today what we're really going to look at, or in this lesson what we're really going to look at, is the connection between multiplying fractions and multiplying decimals, and a couple of different ways we can do that. So let's dive right into it. Okay, our first question says, calculate the product, and we know that the product is the answer to a multiplication equation. So it gives us 34.62 times 12.8. Now, lots of different ways we could solve this, but traditionally I think what most people would probably do would say 34.62 times 12.8. Maybe fill in a zero there if they wanted to make it even, but wouldn't necessarily be required. We're not going to do it that way. We're actually going to use fraction multiplication. And so there's a few other steps here that I will show you, but let's get into it. When I see 34.62, I'm looking at a mixed number. It's 34 and 62 hundredths, right? Times, move over here, I see 12.8. I know that's 12 and 8 tenths. It's an 8 in the tenths spot. Okay, there you go. Easy as that, right? No, not quite. There's a few more steps here. I'm not going to multiply these as mixed numbers. I'm going to create improper fractions. So I know we're going to use our multiply, add, denominator stays the same. So I know we're going to be looking at 100 times 34, which is 3,400, plus 62, which is 3,462, and then my denominator is going to stay the same. So I have 3,462 over 100 times, back over here, I'm going to go 10 times 12 is 120, plus 8 gives me 128. Denominator stays the same, so we have tenths. Now we've got another problem, right? We've got a little bit easier problem, hopefully. We're going to take 100 times 10. We're going to end up with 1,000. And now we're going to multiply our numerators. So we end up with 3,462 times 128. So if you have a calculator and you can use it on the question, definitely do that. But there's no shortcut around this. I mean, there are, but not one we're going to look at right now. So let's do 8 times 2 gives us 16. Drop the 6, carry the 1. 6 times 8 is 48, plus 1 is 49. Drop the 9, carry the 4. 8 times 4 is 32, plus 4, 36. 8 times 3 is 24, plus 3 is 27. My next number starts in the tens place, so my answer is going to start in the tens place. So I'm going to add a 0 in the ones so I don't put the number there by accident. 2 times 2 is 4. 2 times 6 is 12. 2 times 4 is 8, plus 1 is 9. 2 times 3 is 6. Last digit starts in the hundreds place, so I'm going to put 2 zeros here because I want my answer to start also in the hundreds place. 1 times 2 is 2. 1 times 6 is 6. 1 times 4 is 4. 1 times 3 is 3, and we've got some addition to do here. 6. 9 plus 4 is 13. 2 and 2 is 4, plus 6 is 10, plus 1 is 11. 9 and 1 is 10, plus 7 is 17, plus 6 is 23. We have 6 and 4 is 10, plus 2 and 2 is 14. 3 and 1 is 4. So we end up with 443,136. Come back here, and now we have our answer, right? Well, sort of. A couple ways we can do this. I know my answer as a decimal is going to involve these digits, 443,136. That's not my answer yet, because this is essentially dividing by 1,000, which means we're moving our decimal 3 places for the 3 decimal moves here, 1, 2, 3. So I go 1, 2, 3, and I can put my decimal here, which would be 443.136, or 443 and 136 thousandths. The other thing we can look at is we've got this digit, and this is the thousandths place, so that means the final digit up here has to be in the thousandths place. So a couple ways of looking at that, but that's how we get this answer. Let's check out another example. Xavier earns $11.50 per hour working at a nearby grocery store. Last week, Xavier worked 13.5 or 13.5 hours. How much money did Xavier earn last week? Remember to round to the nearest penny. Okay, fairly telling that he earns $11.50 per week times the number of hours he worked, which is 13.5. Okay, a couple ways we can do this. One, first thing we could look at is 11.5, that's about 12. 13.5, that's about 14. If we multiply these two numbers together, we're going to get 168. Now, that's not going to be our exact answer. That's going to be what we like to say is the approximate answer. It'll be around there, but it won't be that exact answer. But we can tell by this that our answer should be in the hundreds of dollars. Now, there might be decimals, right? There might be change, but if our answer is like 1,000 something or 10,000 something or bigger, probably wrong. It needs to be in the hundreds, right? And it looks like it's somewhere around $168, although we rounded both of these up, so it'll actually be a lower answer than that. Okay, let's solve the problem. Okay, I see 11.50. I know that's 11 and 50 hundredths, but I know I can also take off a 0 on the numerator and a 0 in the denominator and end up with just 11.5 or 11 and 5 tenths times 13 and 5 tenths. We're going to use our MAD, right? Multiply, add, and then the denominator stays the same. So we end up with 11 times 10, which is 110, plus 5, which is 115, and our denominator stays the same, times 10 times 13 is going to be 130, plus 5 is 135. Denominator stays the same, so it's 10. We end up with 10 times 10 is going to be 100. And just in the effort, or in kind of the pursuit of saving a little bit of time here, I'm not going to do the full math problem. You can do that. If you can use a calculator, you can. We're going to multiply 115 by 135. We're going to get 15,525. I know I'm dividing by 100, so there's 2 decimal moves, which puts me at $155.25. Since this ends in the hundredths, right? Our last digit is in the hundredths, so that's correct. So he earned $155.25. We'll do one more example here. Important thing here I want to show you. Let's read the question first. Principal of East High School wants to buy a new cover for the sand pit used in the long jump competition. He measured the sand pit and found the length is 29 2/10 feet. The width is 9 8/10 feet. What will the area of the new cover be? We know area is length times width. So we're looking at 29.2 times 9.8. Now, before I do this problem, one thing I can look at, I can do a really quick estimate, just like we did in that last problem. And I can say that, actually I'm going to round that down. I can say that 29.2 is about 29. 9.8 is about 10. So my answer should be in the 290 range. Doesn't mean it's going to be exactly that. If you're a little bit off, don't worry about it because we're estimating, right? So, but we know kind of where we should be. We should be around 290, approximately 290. So I'm going to look at this and say, okay, we've got 29 2/10. times 9 and 8/10. And you use our multiply, add, and denominator stays the same, so our MAD. 10 times 29 is 290, plus 2 is 292, denominator stays the same, times 10 times 9 is 90, plus 8 is 98, and the denominator stays the same. 10 times 10 is going to give us a new denominator of 100. Again, normally I would just write this out and solve it, but just because I'm going to run out of time on the video, I'm just going to show you here that 292 times 98 is 28,616. That's not my final answer though, because I have got to move my decimal twice because I'm dividing by 100, so that's 2 decimal moves. So put my new decimal here. So 286/16 feet squared. I know that this was in the hundredths, so does this end in the hundredths? We have the tenths, hundredths, so that's accurate. We've got our answer. The important thing there, besides being able to do the math correctly, is just showing that, hey, our actual answer is a little bit more than 286. We thought it'd be around 290. We're close, so we're pretty sure that that's an accurate answer. And we used estimation to see that we were in the ballpark. So anyway, that's all I have for you now. We're going to go over some more examples in class. Thank you for watching.